Okay, so 5.3 and 5.4 are definitely things that you've seen before in sixth grade. So we kind of combined it a little bit, and I think you're going to do just fine. So what we've dealt with so far in this chapter is what we call expressions, those algebraic expressions. And that has a variable, an operation, and a number. What we're moving on to now is what we call equations. And I kept this picture down here at the bottom left is because the most important thing about an equation is that it needs to stay equal. Okay, and then again, that's kind of your clue. So like this scale would need to stay balanced. So an equation is a mathematical sentence, because remember, algebra is about translating our verbal phrases into math. So it's a mathematical sentence formed by placing an equal sign between two expressions. So that's kind of the clue, is whenever you see an equal sign, then you know that that's going to be an equation. So here's an example. I have some unknown amount. I add 2, that is going to equal 5. So the way I would read this is x plus 2 equals 5. So a solution to an equation is what will make this a true statement. So what could I put over on this side that I can add 2 and that would equal 5. So a solution of an equation with one variable is a number you can substitute for the variable to make the equation 2. So for this one up here, we've seen this, and you could do it with mental math. We're going to be pretty specific about making sure that you write this stuff down. But let's just take a look at this. Oh, what number plus 2 equals 5? Yep, that's going to be 3. So 3 plus 2 would equal 5. So 3 is a solution. Okay, so how can we find those solutions without doing mental math? Again, it's always going to be, if you can, you would want to use mental math, but there's going to be some situations that you're going to want to, you have like 2 or 3, 4 different operations that you have to do in order to solve it, so you're going to want to make sure you write it down. So we use what we call inverse operations, and it's an operation that undoes another operation. So I like to think about it as wrapping a gift and then unwrapping it. So whatever you do to wrap the gift, to undo it, if you did it in a nice organized way, would be unwrapping it, and you'd get back to your gift. So we know that addition and subtraction are what we call inverse operations. They undo each other. And then multiplication and division are also inverse operations. So if I had this variable x and I add it 2, I would have to subtract 2 in order to get back to my original gift. If I had x and I divided it by 2, I would have to multiply by 2 to get back to my original x, because this would cancel out. Oops, that would cancel out. So again, you're going to undo what you've done. So I like to call this gift wrapping 101. So let's take a look at the steps you would take to wrap a gift. First thing you have to do is, where's my cursor? Put the gift in the box. And then you wrap it with paper, and then you stick on a bow. Now, in a perfect world, we all know we would take off the bow, take off the paper, and then take out the gift. So this would be the process that you would go through, is you unstick the sparkly bow, you unwrap the paper, and then you finally take it out of the box. So notice that the first thing you did here was the last thing you did here. And that's again, going to be very important when you start getting into multi-step equations. So let's take a look at some examples. So you're going to solve the equation and check your solution. So let's take a look at this. X plus 9 equals 20. And I know some of you are like, oh, I know what it is. I can figure it out in my head. I don't care. I want you to write it down. So plus 9, x, I'm adding a 9. To undo adding, I need to subtract. So I'm going to subtract the left side by 9, and I'm going to subtract the right side by 9. So this becomes plus 9 minus 9. They cancel each other out, and I'm left with this x. And then 20 minus 9 is going to give me 11. So my solution is going to be 11. And I'm going to double check that. 11 plus 9 equals 20. Yep, check my solution. Okay, so it's important to remember that whatever you do to one side of the equation, you have to do the same to the other because you want to keep it fair and balanced. Just think about that. If your brother got $5, you better get $5 too, or you're going to be mad, depending, you know, if it was an allowance or just because. So you want to keep it fair. You don't want to create some type of chaos like stitches over here. You want to keep it nice and organized. And you'll thank me later, trust me, when you get up into algebra, geometry, and algebra 2, and calculus, and all that other fun stuff. You'll thank me later for staying nice and organized. All right, so let's just practice some examples. And again, the variable can be on either side. If it helps you to actually think about this as a gift, you can put a box around there. You can put a circle around it. You can put a star, whatever. So right now, 6 is being added to x. So to undo addition, I have to subtract. And if I subtract from the right, I'm going to have to subtract from the left. So 6 minus 6 cancels each other out. And you're going to be left with x. 23 minus 6 is going to give me 17. Now I'm going to double check this solution. Does 6 plus 17, 6, I break that into 3 and 3, 17 plus 3 is 20, 23, yep, that's a check. All right, so here we go. So the gift, and again, you don't have to box it, but if that helps you to kind of say, okay, I need to isolate this all by itself. So right now I'm subtracting a 4. So to undo subtraction, I have to do addition. So I add 4 to both sides. So this is going to give me C, because minus 4, if I took $4 away from you and then gave you back $4, that's going to be like nothing ever happened. So these cancel out. And then 13 plus 4 is 17. So I'm going to double check and say, does 17 minus 4 equal 13? Yes. Now it's just a coincidence that they both end up 17. I just made these problems up. Alrighty, and again, it doesn't matter which side of the equation that has an equal sign does our variable sit on. So right now, y, I'm just going to box it just because you can. Y minus 15, to undo a subtraction, I'm going to add. So I add 15. I want to get rid of this whole 15. So I'm going to add 15 on this side. And that's going to give me 9 plus 15 is 24. And I'm going to do a check on this. Does 24 minus 15, what does that give me? I'm going to borrow from this guy. That gives me 9, 0, yep, equals 9. So that is your solution. Okay. Now, we're doing multiplication and addition. So let's take a look at this. This gift is being divided by 3. So to undo division, you need to multiply. So I'm going to go ahead and just change the color. so you can see. So I need to multiply by 3, and I need to multiply this side by 3. And I'm just going to rewrite it over here so you can see it a little bit better. Divided by 3, and then 5 times 3. So whenever you're multiplying a whole number by what you would consider a fraction, what you can think about this too is this 3 is being canceled out with this 3 here. So it's being divided into 1, because 3 divided by 3 is 1. So the y is going to be left, and that's going to be 15. So let me do a check on this solution. Is 15 divided by 3 5? Yep, that's a check. All right, and again, it doesn't matter which side of the equation do you have the variable. So let's put a little box around it. Again, you don't have to do that. That's just a kind of an indicator that we're isolating this. So I'm dividing by 9. So to undo my division, I need to multiply. So I'm going to multiply both sides by 9. I can't just multiply the right because he's going to get mad. I have to multiply the left. So 9 times 2 is 18. 18, this divides out to 1, and you're going to be left with x. So x equals 18. And let's just double check that. Is 18, divided by 2, or 18 divided by 9 equals 2. Yep, that's a check. All right, one more operation. We went through addition, we went through subtraction, we went through division. Now we're going, multiplication. Now we're going to go through division. So here we go. I have my variable x, and I need to isolate it. Keep it all by itself. Right now it's being multiplied by 9. So I need to divide by 9. And if I divide the left by 9, I have to divide the right by 9. So this divides out to 1. Be left with x equals 6. And if you did a check on that, 9 times 6, got to remember your multiplication. 9 times 6 is 54. Check. Now, does it matter which side this variable is on? If it's on the left or the right? No, it doesn't. But guess what you get? You get your little negatives now. And you get decimals and fractions and all that fun stuff. But we're just doing some basic problems right here. Okay, so again, you don't have to put this x here, or sorry, the box, if you don't want to. So some number is being multiplied by -3 to get 48. I don't know what it is, but I'm going to find out. So to undo multiply by -3, I have to divide by -3. I have to get rid of all of this. So this divides out into 1. And if I multiply this right side by -3, I better divide the left side by -3. So let's say that this doesn't stand out at you. You got to do it old school. 48 divided by 3. 3 goes into 48, or goes into 4 one time, and then you get 3, 1, 8, gives me 6, 18, 0. So it's terminating. So it's x is going to equal, now remember, a positive divided by a negative is going to give me a -16. Okay, so again, you got to be careful. You're in 7th grade now, so you get your little negatives. And next section is going to be 2 steps. So let's appreciate the fact that these are just 1-step equations. Let's make sure we have mastered our integer rules, and we remember the inverse operations for addition, subtraction, multiplication, and division. All right, see you in class.